Number one, so what is electric potential energy? It is exactly what you're thinking it is. It's stored energy due to electric charges. Specifically, it's due to their position in an electric field. Now, that field can just exist, or that field can be created by another charge. It honestly doesn't matter. It doesn't matter whether it's just a field that exists. It doesn't matter if it's a field created by another charge, whatever the case may be. But it is a field that's created. Now, I'm going to give you an equation for this. Not because you're going to have to solve problems for this, you're not. The reason I'm going to give you the equation is because it will help you see what affects this potential energy. So electric potential energy is equal to Q E D. So Q is the charge that feels the energy, that has the energy. E is the electric field it's in. And D is like the distance. The easiest way to describe D is it's the distance away from the source of the field. But there's an easier way to describe that. Here's what D is. D is height for grav. Here's what I mean by that. Remember when we did gravitational potential energy, and it's mgh? Okay, m is q, right? The mass of the object is what has the energy. The charge of the charge has the energy. G was the gravitational field. E is the electric field. H was how high above the ground it was. D is like how far away you've moved that charge from the field. That's what D is. D is kind of your position of your charge in the field. Okay, that's kind of the hardest thing to understand here. Just keep in mind, you want to understand the idea, which is it's energy stored because of where it is in a field. That's the key. Okay? All right, so what is electric potential? And yes, it is something different. We did call something electric potential energy and something electric potential. So electric potential I like to call, let's use a different color so we don't get all of these things confused. Electric potential I like to call stored, let's call it potential stored energy of a field. It's how much energy a field can create, but isn't created. And if that sets off little buzzwords, didn't we say something like that last unit, that something like could do something but wasn't doing it? Yes. Electric potential is to electric potential energy what electric field is to electric force. Electric force is the actual force between two charged particles. Electric field is the force that would be created somewhere from this particle, but there isn't another particle there. Electric potential energy is how much energy a charge has. Electric potential is how much energy would a charge have if there was one here. Okay, so if this is my electric field, and I want to look for the electric potential at X, I'm just asking how much energy exists here. Not how much energy does charge 1 have. I'm just saying how much energy exists in that field. And the reason for this is exactly the same reason for field. Sometimes I don't have charges there, but I still want to know what happens. Right? So maybe I don't have a charge here at this spot, but I want to know what happens. Or here's what's more likely. What if I don't know how much charge there is? There's like some, I see it that's over there, there's some charge, but I don't know how much it is. I still want to figure out what's going to happen. I just don't know the exact value for the charge. I can use this to figure it out. And here's the equation, by the way. The equation is, so electric potential, by the way, is, let me make sure I'm getting the equation set up right for you. V equals PE over Q. And V, by the way, is electric potential. I know that's totally obvious. I know you're probably saying to yourself, oh, when I think of the word electric potential, the letter V comes to mind very quickly. Luckily, this one actually will make sense in about 2 minutes. Okay? So, electric potential is how much energy exists in a field if I don't know how much charge is in the field. Just in this area, how much energy would we have? That's the idea for electric potential. Okay, one more weird thing, one more weird word. Electric potential difference. At this point, you're thinking physicists are just making up words. They're just like, oh, hey, the word difference is in the dictionary. Let's add that. Here's what electric potential difference is. It's actually very simple, even if it seems very complicated. It is the difference in electric potential between two positions. Electric potential difference is just a more specific version of electric potential. It's saying, if I have my field here still, boom, boom, boom. It's saying, what's the difference between A and B? That's all it is. It's just saying, what's the difference between A and B? How much electric potential is at A compared to how much electric potential is at B? Because the electric potential we'll get to in a second describes why everything happens. So if I can figure out the difference between A and B, I can figure out, is it going to be a large effect? Is it going to be a small effect? Is it going to affect a lot of charge? Is it going to affect some charge? Is it going to be easy to create? Is it going to be hard to create? I can figure out a lot of things by figuring out the difference between A and B. So electric potential is just like position, right? I'm at X. I don't really care about that. What I care about is how far did I go? Displacement. Potential difference is like displacement. It's what's the difference in the energies between these two spots. That is very useful. This is not near as useful. What is useful is figuring out what's essentially delta V, the difference between those positions. Okay. Any questions up to this point? Because I know I've thrown lots of words at you. But this is the part I'd say it's going to start getting simpler again. Okay. What is voltage? All right. Voltage is electric potential difference. Now you see why it's V. Okay. Electric potential difference, we call voltage. So now you're like, oh, okay. So like when we're talking about the voltage of a battery, this is what we're talking about. Yes, that's exactly what we're talking about. Here's a battery. If a battery has 1.5 volts, that's the voltage of a AA battery. What does that mean? It means the difference in the electric potential between the positive side and the negative side is 1.5 volts. That's what it means. Now you might be saying to yourself, well, why don't we use energy? Why don't we know how much energy the battery has? Because I don't know how much charge is in a battery. Right? We put some charge in it. I don't know how much is in there. Some charge. not 0. But here's the other reason why potential difference is good. As you use up a battery, the electric potential energy changes. The electric potential does not. Remember, it's independent of charge. So I don't care how much charge is in the battery. The difference in energy is the same. That's why we use electric potential difference, because that number does not change no matter how old the battery is until it's all used up. Yes?
So the electric potential energy changes, but the electric potential does
Yes. Yes, that's an excellent connection. The electric potential does not. The electric potential energy does change. Yes. But since we don't really need to use the electric potential energy, we stick with this. Which brings us to number 5. Look, we're almost done. There's no back page. Snap. I know. All right, number 5. Ugh, why does any of this matter? That's a great question, annoyed physics student. So, why does any of this stuff matter? Here's why. I'm going to tell you what each of these things are and what's important about them. Okay, so what's important about electric potential energy? Here's what's important about it. Electric potential energy is the cause of voltage. So without any energy, there would be no potential difference. Okay? There would be no potential difference. Without any energy, there's nothing else. So the reason why electric potential energy is important is because it's what makes this exist. Okay? So the reason why electric potential matters it matters because it's a way to analyze electric potential energy if charge is unknown, which is very common. Or, as Sam pointed out, if the charge is changing. So this is a way that we can actually look at the energy and figure it out. Okay? Electric potential difference matters is because change is what's really important. Which brings us to the last one, voltage. Voltage matters because it's what makes circuits work. It's what makes circuits work. Without voltage, circuits don't work. Voltage is like the pump that makes electrons go through something. Yes, Andrew?
What's the second electric potential?
Oh, yeah. You didn't see this difference? Oh, yeah. Yeah, this one's electric potential difference. Is that your question, Sam? Yeah, it's electric potential difference. That's my bad. Yes?
Electric potential difference, does that say charge is what's really important or
Change. Change is what's really important. Where are you, mouse? There you go.